We're going to apply points to some different things that are important for chainsaw sharpening and safety in general, cutting techniques. And I just want to kind of give you a little bit of idea. Soren is kind of correlating it to soccer, which when it came to the States, he had to kind of change to football. So we call it game of logging. But it's something where, you know, he always said that very few times do you ever see people that if it wasn't up here at 2 o'clock in the morning, they're not going to pull an owner's manual out of their back pocket or whatever and start to review stuff. Whatever that you think about to get people to use has to be up here. And how do you get people comfortable with it? We started looking, we're going to talk about reduced downtime, maintenance program, all this kind of stuff. We started to look at, you know, if you go to the owner's manual, there's about 15 different things to look at, check out your saw. People aren't going to go, and so we started to think about 5 areas, kind of condense it down, the most important ones. And usually that turns into kind of an overall picture. And when it came to sharpening, we look at really how are you going to sharpen if you don't understand the functions of each part of the tooth. I want to kind of throw out something I came across just a few weeks ago. We were doing a session in Albany, Georgia. And I had a fella, and I started going over the tooth. And he came up to me. He said, you know what you're talking about with the 5? He said, that's important to be able to think through it and repeat it. He was a Marine. He said retired Marine. Then he said, nobody's a retired Marine. You're always a Marine. You know, he said, you know what you're talking about there? He said, I want to share with you a story. So he came up to break. And he said, my drill instructor there at Paris Island, he said, we first all showed up. One of the first things he wanted us to do is be able to take our rifle apart and put it back together. And so from day one, you're going to take your rifle apart. And they had M14s, he said at that time. He said they'd take it apart and put all the parts out in one order and then put them back together in one. He said every day we had to do that. Guys got to thinking, hey, it's like you're saying, oh, we've been doing this, you know, we understand, we don't need the chaps, we don't need all this kind of stuff. And he said every day, he'd make us take those things apart, put them back together. He said, we got down to the last week. We were about to graduate. We all got in the room that morning. He said, well, just for old time's sake, we're going to do it again. He said, y'all get together. He said, we're going to work in teams on this one. He said, we're going to do the rifle drill. Guys were just complaining, you know. He said, okay. And he started handing out blindfold. And he said, both of you put on the blindfold. One of you choose to take it apart. The other's going to put it back together, blindfolded. He said, you know, you may need this one day. He said, this part's for life. I got to think when it comes to chainsaws, maybe we don't want to put on blindfolds necessarily, but basically, why do we not do stuff? Why do we not sharpen? Why do we not maintain the saw? It's generally because we're not comfortable with it. It's how many times we do it to get comfortable with it. If we're comfortable with it, you see everybody start to participate with it. This is called RDT, and that stands for reduced downtime. It's not the cost of cylinder piston or spark plug or barn chain or whatever that really gets expensive. It's when you pick it up at 2 o'clock in the morning to go do a job and it won't work. Somebody has put it back up, rode out hard, not cleaned up, not sharpened, won't run, you know, it's out of gas, it's whatever it is. They pull on that thing 8 or 10 times, it don't start, you're ready to front kick it across. Yeah. And I see that quite often with just simple adjustments. Now I don't want to try to turn you into two-cycle mechanics, but I want to kind of go through a little bit of a situation with understanding two-cycle and how important it is to keep everything clean and all. This would be 5 areas of the saw that are important for that piece of equipment to mechanically operate. What do you think the first area should be? In other words, if you want to take a look at your chainsaw, what would 5 areas be that you want to make sure is mechanically going to do the task?
Air breather.
Air filter? All right, I'm going to put that down on number 2 here for my little talk. What else?
Fuel.
Fuel in there, fuel and gas. Oil, I'm going to put that down on the visual over. That's a what?
Trash buildup around the clutch.
So some cleaning,
yeah.
A little bit. And that probably you can put it under visual or under air filter or just the total cleaning of the unit.
The rope. The rope.
Mm-hmm. Have you ever tried to push start a chainsaw?
Yeah.
2 more.
Bar.
Chain, bar, and sprocket. Really the work sides. I'm going to put that down here. Chain, bar, and the drive system. 1 more.
I guess you tripped.
Nut screws, both sides, probably under visual check. Safety features. They say safety number 1, right?
Yeah.
So safety features, and that's kind of the 5. If I ask anybody around the country, that's kind of the 5 that they come up with. And I want to go down through just a little bit quickly and just kind of talk through what should be checked and why, okay? And just so you got an idea here, it has to be checked before you go to work, and then probably making sure it's all there when you finish up. But the first one is on the safety features is a throttle interlock. So you want to make sure that you got this hand under this before you can accelerate. Another one, if you operate a chainsaw long enough, you're going to end up with the chain jumping off. And when it does, this little chain catch. Some are aluminum, some are plastic. And then the third one that's on all saws is a handguard. When the B175 ANSI standards came out back in the middle 80s, set of features that had to be on all saws, all the manufacturers got together, kind of a voluntary standard. OSHA kind of picked up on it after that, started following the ANSI portion of it. Should be on every saw. And then they started to come up with a kickback test. That was a couple years later, and more or less, one of the things they had to be on every choose to go with a chain brake assembly. What they do is they put it into a rig, they would run a piece of wood into it, it would kick, and it had to trigger the brake and all before it got within 45 degrees of the operator. So the manufacturers had a choice. They could go with the chain brake, or they could go with what's called a guard tip. And I saw those on the CHAMP program last week also, but basically the bolts on here covers the end, it can't kick. I'm going to take and look at putting it back on. Now this one just got one nut, but it sits over the studs, and I see all the time what people try to do. They try to set the saw like this. Every single class, I see this. And people take the bar and they try to put the chain onto it, right? And then they got to put it on. And if they put it like this and then they're not watching, they put the chain on backwards very quickly. But here you can go to this side, then you try to go over the drum, then you got to get it over there. It takes like 5 hands. But what I noticed on that competition with the fast guys and ladies, they put the saw flat. Take the bar, set it on the studs. After you got it on the studs, you make sure your depth gauge is forward to the point on top of the bar. If you turn it that way, it stands the trees back up. Do that. Now we go around the drum, go into the sprocket, lay it into the top rail, and push back on the Husqvarna. The steel's got to come off the adjuster and go back. Go around the tip, take your gloved hand, grab the bar, pull, go up on the stud. I mean, it takes one hand instead of sitting there trying to do it for 20 minutes. And I mean, I'm still slow at it, about 39 seconds or so. But it's something where if you really practice it, it gets faster and faster. And then on these saws, you've got the adjuster pins on the outside. The others, when internal, you've got the adjuster pin on the inside. And so here, you got to line that up. So that goes on, turn it counterclockwise till it drops into the adjuster hole, close it up. Then you start your stud or stud nuts, just finger tight. Then I'm on a proper adjustment. I pick up on the end of the bar just slightly, and then turn it till it just touches the rails. You see, if you tighten it up too much, you have resistance. And people don't realize how important that is to cutting speed. You can have your chain set tight, and it's not going to cut because that chain has to rock and roll to take the chip. It has to be able to pull out of the rail to cut. People don't realize. That's the reason why I say, I'll show you something. You pull back just a little bit, it really starts to feed. And so that's how the chain works. If you got it hanging down and it bunches up, it can't. It's going too much. And so it has to be proper adjustment to really cut fast. You know, I find a lot of times when people say, well, my chain loosens up all the time. I don't think my oiler's working. And I had one of the guys in West Virginia at DOT. And the guy was asking, can I bring my saw tomorrow? I'd like you to look at mine. I don't think my oiler's working on my saw. I said, well, yeah, you can bring it in. One of the guys back in the corner, I said, what'd you say? He said, metal don't smoke. Yeah, I said, what do you mean by that? He said, well, he's talking about his bar is smoking. If he's smoking, he's either burning oil or paint off of it one because metal don't smoke. He said, you can get it red hot or you can get it white hot. He said, metal won't smoke unless you got impurities. He said, but if you've got oil or paint on it, it's going to burn it off if you get it hot. So what's causing the heat? You push on this metal against metal, heat goes up quick. And so if you got dull saw chain and you're pushing on it, bar and chain temperature in Oregon show me can go up to close to 1,000 degrees on some of their tests. When you pull the rope, this piston goes up and down. When it goes up on a 2-cycle engine, it's creating a negative pressure down here in the crankcase. Piston goes up, it creates a negative pressure, just like sucking through a straw. It pulls air through the filter. Then it goes through the carburetor. It squishes it down as it goes through the carburetor. 2 things it does. It picks up velocity and it cools it down. So when it goes through there, then it starts to suck fuel out of the nozzles in the carburetor, and basically then that fuel and air mixture is pulled down this port and goes into the crankcase. A lot of people don't realize that. A 2-cycle engine, whether it's this motorcycle outboard, it goes through the crankcase first. Why would it go there? You don't have a quart of oil or 6 quarts like in your vehicle down there. The only lubrication the rod, the wrist pin, the crank, and the seal gets is what's in that gas mix that you mixed up. And so it's mixing with air going down there. Then the piston goes down. It makes a positive pressure down here in the crankcase, and it pushes it up this port and to the top of the piston, combustion area. So piston goes up, fills the bottom. Piston goes down, pushes that mixture up to the combustion area. It goes back up, it's filling the bottom, just before top dead center, bam, the spark plug fire. And now it's all doing it automatic. Piston goes up, fills the bottom, piston goes down, fills the top, piston goes up, fills the bottom, before top dead center, bam. And then that last little bit of movement area up here in the top dome of that cylinder pushes those burn gases out into the exhaust. If you have a 50cc engine, that's about the average cylinder saw size, about 3 cubic inch. Every time that piston goes up and down 50 cc's, it's pushing out 50 cc's. That's what I call a 2-cycle. Happens in 2 strokes. So let's think about this. Let's go to the adjustment. And I will give you this one first. The first thing you've got to make sure is the air filter is clean. I have people all the time say, oh, my saw doesn't start like yours. You know, it doesn't start up very easy. It keeps getting flooded, all this kind of stuff. Air filter maintenance has a huge deal to do with this, because I want to explain to you this way. Let's take, for instance, that air that 50 cc's is going through. Let's say that our filter is half dirty. What do we just do? We just reduce down the amount of air that's going through there. But it's still got the same pull from the crankcase, so what happens to the fuel in the carburetor? It's still going into the airflow. Now you got more fuel, less air down here than that thing can eat, because you got to have a 14.7 to 1 air to fuel ratio for a fire to burn or explode, because you got enough air to create the burn. You got to have 1 part of fuel and 14.7 parts of air to be able to make that burnable combustion ratio. If I richen this up, I've got more down here than I can burn. It just starts to back up everything. It's like having what? Flooded saw. And so if you've got dirty filters, your saw is going to be hard to start, guaranteed. And then I start it up, I let it warm up. I take my brake off, I go to high speed, comes up, levels out. I let off the throttle, my chain stops turning. I put my brake on, I can roll it around, continues to idle, because that's where it'll show up. If I've got more fuel that it can burn, you'll choke it right down when you roll it over. Then I want to make sure it accelerates, take the brake off, I hit the throttle, it should accelerate back up. If it does all 5 of those, it's ready to go. That dog's ready to hunt. But that's kind of the process we have to go through. That chainsaw is nothing but an air pump. 2-cycle engine is nothing but an air pump. You took a 4 cubic inch chainsaw that all of a sudden is down to a 2.5 cubic inch chainsaw, simply because the operator didn't clean the air filter. If you go out west, you know, guys, if you were to take the average saw we use here, 3-4 cubic inch, and you take it out to Mount Shasta in California, and you start to cut at 7,500 feet, that thing won't even hardly run. You know, that's it. That's the reason why you have to have a big saw if you cut at higher elevations, because, as they say, there's no replacement for displacement. The notch has such a big factor because it allows the hinge to work. Remember that? And so we use a percentage here, 10% of the diameter of the tree in width of the hinge, 80% of the diameter of the tree in length of the hinge. So if we've got a 12-inch tree right here, our hinge would be a maximum of 1 1/4 inches. The length of it would be the back of our notch is the front line of the hinge. And that we want to be a minimum of 80% of the diameter. That would be 9.5 inches roughly. Fiber there, actually, dried fiber is stronger than green fiber. I mean, if you're going to buy a 2x4 to build something with, you don't want a green one, right? Because it's too flexible. It's flexible. A dried fiber, though, goes so far, and then it's going to do what? It's going to snap. A green fiber is more flexible. It's more pliable. And so hopefully you've got green trees to take care of, but because it's hard to figure out how much movement you have on the dead stuff, but it is something to where actually you probably want thinner on dried fiber than you do on green fiber. Now, the difference there is it a dead tree or a rotted tree? You see, you've got to have fiber for a hinge to work.
Gotcha.
So if it's just powder and rot, it's all gooey and wet,
yeah.
That's not a hinge.
Gotcha.
You start thinking through it a little bit though, the face notch really determines how far that hinge is going to move before it snaps. Let's take, for instance, you got a dead pine tree to take down. If y'all fell a tree, that's probably what most of it's going to be, isn't it? And so you start to think about it. If you put a 45-degree face notch in that tree, and it's leaning forward or whatever, when it closes that 45-degree notch, what happens? It has to break the hinge, doesn't it? At that point, what's the top going to do? It's got to shake, doesn't it? And what happens in many cases with a dead top is it's more rotted in the base, and you end up with it folding back. Or so it's called a standard, or a force calls it conventional notch. And so it's usually written up to be about a third into the diameter of the tree, 1/5 high, which gives you an opening of about 45 degrees. That's the common or standard. And then this one is, if you don't watch Axemen on TV, it's called a Humboldt. If you go to the West Coast, just about every tree that's cut is used with a Humboldt. And the reason being for two things. Larger diameter trees are usually up on mounds, and so they find it easier to cut in straight, take it out the bottom. Also, they ended up with a big diameter tree, didn't have to rebut it to go to the mill. So it's a little bit more effective for their scaling purposes. And then the other thing is that they found out the bigger trees, basically the stump came down at an angle, hit, and then the top hit. If you use this, usually it stayed kind of attached, and the top hit before the butt, and you ended up breaking tops on real brittle trees, Douglas firs and redwood and stuff. So basically the Humboldt was adopted on the West Coast, and still today just about everything is felled that way. And then this one is what Soren kind of pioneered into the States, we call the open face. This one was actually written up to be close to a half into the tree, and then taken out, and they usually have had it written at 45, but a lot of times I don't see it that much. You could make it more than 45. But this one is open face is written up to be 70 degrees plus. Now what you think about this? This tree starts to fall, how far is it going to go? It moves over 45 degrees, the face notch closes, at that point the hinge has to give. This one, basically same thing, this is 45 degrees, it moves to that position. This one basically goes all the way down to 70 degrees before the hinge is disconnected. And I guess my theory is, why do you want to stop the tree halfway to where you want it to go anyway? Beautiful site for training. We were back in here. This is some Georgia forestry, their training area for controlled burn and looking at different things. We did a saw class back in here with the supervisors about 2 or 3 years ago, and it worked out really well. These pines and all in here, they're pretty healthy and things work out pretty good. It can come out overall pretty healthy little forest. Back in here in the morning, we're taking some trees down, making some storm situations, and see what we can create for some pressures and binds. So what it did is you had to lean to that side and you cut the hinge off. So what did it do? It just kind of set over on the bar. It didn't really go back. See the compression? So you got to concentrate, keep everything level. And so you're out on the road cleaning up after a storm. We've got a tree across, we need to get it out, clean it all up. And you know, it's an oak tree with quite a lot of mess here. Where do we start? Where do we begin? It all goes back to the planning process. How we need to cut it to be able to move the pieces, put together a plan on each cut, and work towards it. Well, that's what we've got. We got a little going on here with the Georgia DOT, and they're kind of a train-the-trainer class. They're looking at being able to pass along information to co-workers and new employees. And in this case right here, they dropped the trees down today. We've made the piles, and tomorrow they'll be working to clean it all up. So it's gonna be quite interesting. Looking forward to it. This way and then overcut at an angle this way, and then that way you've got the bottom cut on the compression side pretty much. Don't have to be all the way under it, but like here in this position, I'm gonna come up this angle and then offset this angle.
I mean, instead of down more this way, just come in at
yeah,
an angle,
yeah,
and then angle here.
Same angles, yeah.
Now what's your width? Does that matter?
I mean, if you got a piece of equipment coming, you could offset that thing a foot or two.
Okay.
And that piece of equipment hits it, it's gonna pop apart.
Okay.
If you
And the best way to cut this tree is to relieve the pressure, because if we do not take the compression off, the most likely it will get stuck, it will cause tension. But not only that, we're going to take the existing branches off as well, in case it falls, might cause it to roll or, yeah, exactly. Now go around. Keep the tips centered in the middle.